When Lamborghini engineered one of the most visually aggressive supercars in history, they didn't test it in a climate-controlled multi-million-dollar wind tunnel. They taped pieces of scrap yarn to the metal and drove it down public Italian streets. To understand why they resorted to this, you have to look at the situation facing Ferruccio Lamborghini in 1970. His previous masterpiece, the Miura, had practically invented the modern supercar, but Ferrari was rapidly catching up with their front-engine Daytona. Ferruccio handed his engineers a massive problem. They couldn't secure their lead by simply building a slightly faster Miura. They had to invent an entirely new mechanical and aerodynamic baseline. To beat Ferrari, Lamborghini had to rewrite the physical and aesthetic rules of what a road car was allowed to be. They handed the exterior styling to Marcello Gandini, a designer in his late 20s. He threw away traditional curves and drew a violent, geometric wedge. The radical shape defied convention so thoroughly that when a local Piedmontese factory worker saw a late-night mock-up, he involuntarily shouted, "Countach," a regional dialect curse expressing extreme astonishment. The name stuck. At the 1971 Geneva Motor Show, the public saw the LP500 prototype for the first time. With its upward-swinging scissor doors and bumperless nose, it looked like a crashed UFO resting on the grass. Gandini drew this spaceship purely to shock the eye. He didn't run a single mathematical simulation on the shape, which raises a massive engineering problem. How could a drawing based entirely on aesthetics survive the brutal physics of 200 miles per hour? Making this wedge physically drivable fell to chief engineer Paolo Stanzani. He had to fix the old Miura's fatal flaw, a transverse or sideways-mounted V12 engine that caused terrible weight distribution and chronic overheating. This top-down blueprint shows Stanzani's solution, the longitudinal posteriore layout. By rotating the massive V12 engine 90 degrees, he aligned it front to back down the center of the chassis. Because of that rotation, the gearbox shifted completely out of the rear and into the middle of the cabin. This placed the heaviest components directly between the driver and passenger seats, perfectly balancing the car's mass between the front and rear axles. Stanzani then wrapped this balanced powertrain inside a hand-welded tubular steel space frame, a rigid skeletal structure pulled directly from Formula One racing. Beneath the sci-fi body panels, the Countach was a rigidly calculated, mechanically flawless racing chassis. But mechanical balance only gets you so far. Lamborghini couldn't afford time in an aerospace wind tunnel to figure out if Gandini's wedge would actually generate enough downforce to stay on the road. Test drivers Bob Wallace and Valentino Balboni had to devise an analog solution. They took hundreds of tiny wool tufts and taped them directly over the prototype's body panels. They then drove the prototype at 160 miles per hour down public Italian highways. The drivers had to read the fluttering wool to visually map the airflow across the metal, making mental notes of aerodynamic lift while dodging vintage farm tractors. This chaotic, high-stakes testing environment forced Lamborghini to solve deadly high-speed instability using pure human intuition and bravery, rather than sterile laboratory data. Over the next 2 decades, the car continued to physically evolve based on extreme market demands. The first major shift came from Formula One team owner Walter Wolff, who demanded more mechanical grip from his personal Countach. Lamborghini responded with the LP400S package. They worked with Pirelli to mount the largest road tires ever made, which were so wide they required massive fiberglass wheel arches just to cover the rubber. Owners also began demanding the aggressive V-shaped rear wing seen on Wolff's car. Ironically, while it looked aerodynamic, the wing caused massive drag and actually reduced the car's top speed by 10 miles per hour. By the late 1980s, a young engineer named Horacio Pagani joined the team. He pioneered the Countach Evoluzione concept, replacing heavy metal with a carbon fiber composite chassis, a woven, ultra-lightweight material that set a new standard for supercars. The Countach continuously adapted across 2 decades, absorbing the reckless excess and material innovations of the 1980s until its final production run. Decades later, aerodynamic engineers finally took the 1970s Countach design and subjected it to modern computational fluid dynamics, using supercomputers to perfectly simulate the physical behavior of air. This 3D simulation reveals something remarkable. The extreme angle of the hood perfectly slices the oncoming air, creating a seamless, unbroken flow that travels right over the flat roof. Underneath, the sharp front underbody naturally accelerates the air. This speed difference creates a localized low-pressure vacuum that actively pulls the nose down toward the pavement, compensating for the messy wakes created by the massive wheel arches. The computer simulation returned a final drag coefficient of 0.46. Without intending to, Gandini's aesthetic sketch and Balboni's wool-tuft road tests had achieved highly functional fluid dynamics. This experiment resulted in the cab-forward wedge. By shoving the driver to the very front to make room for a massive engine in the back, the Countach established the exact silhouette used by almost every mid-engine supercar on the road today. In today's automotive industry, algorithms and digital wind tunnels dictate shapes, producing vehicles that are mathematically perfect but often visually sterile. The Countach remains the defining supercar blueprint. Its bold, rule-breaking intuition proved that unapologetic art and brutal physics can successfully collide.